Yeah, hello everyone. Am I audible?
Yes.
Yeah. Good evening, everyone. So I hope you all are joined. We'll wait for 1 or 2 minutes more and then we'll start. Yes, Gautam. Good evening. So now we shall start. Let's say yesterday we were going through that OSI model and all that we have came across. There are some sort of layers. So OSI model is a layered architecture. Okay, like it is the rule how your packet will be uh, going through this internet and all. So that means how whatever data we are doing right now, we are on the Zoom session now, whatever the data is I'm transferring you, so it is going through all those OSI layers and it is getting processed accordingly. So OSI, it is a booklet of rules, how the internet would work and how what kind of, depending upon the data, maybe it is a voice, maybe it is a photo, maybe it is a text, whatever the data is, they would represent as it is. So now we will actually discuss one thing. There is something called server. We always know, okay, when we have to uh, go to google.com or when we have to go to cisco.com, everywhere, this term server would come somehow. So why do we need a server? What is the need of a server? Why?
Ma'am, your voice is not so clear, means.
Okay, am I not audible clearly?
Ma'am, the voice is audible, but it is not clear, means.
Okay, so is it common to all, or maybe
No, from
No,
ma'am,
ma'am.
I'm
No,
listening you
no.
proper. Here is
No,
perfect
ma'am,
for
it's
myself.
okay. Perfect.
Okay, maybe Gautam, you can just check your speakers once.
No, it is audible, but not right now. It's okay.
Okay, all right, fine. Okay, so when we say server, let's say, just take one more daily life example. I book one appointment with my dentist, and then I go there. So dentist would be actually the one because this is a problem, specific problem that nobody else I can actually sort out the problem from. So if I have some problem in my teeth, definitely dentist is the only solution for me. So that means I have to book one appointment with doctor, and then after I'm in dentist, then that dentist will be whatever the services they need to provide. After that, they will be actually I'll be coming from their clinic or whatever. So whenever we say we are going to have one appointment, that appointment can be with one of the bank of officers, It may be one of your doctors, it may be with any visa officer, anything. So whenever we say we do have one appointment, that means one of you. So one of you will always be serving its duty. So that will be on duty. Because that guy has to, that is the role, that is the responsibility of that guy to serve you. So similarly, server is that kind of guy that has a duty to serve you, that you cannot get it done from any other device on the internet. So whenever you come across this www thing followed by any
Can you please,
website.
ma'am, repeat the server thing, ma'am, this example? I didn't get that.
Okay, so the example is, for example, when we book any appointment with anyone, right? So the other person, it might be your doctor, it might be your advocate, it might be anyone. So that guy we normally see in real life, that is on duty, right? So you are actually seeking some services from him or her. Same thing you can correlate with the server. Server is a device that is actually you have to have one session. So we normally call it session layer is responsible for all of this stuff. So session, you have to establish one session with the server, and then that server will be the one who will be sorting out everything, whatever you are typing in your browser, for example, cisco.com, whatever you are doing. So we can say these things are programmatically mentioned, like how to do with this all stuff. But now from reaching to internet and going from one router to another router, one country to another country, how the things are being going on, that is the process of routing. Okay, so routing of what? Routing of your data. So this routing will say, this is that kind of web traffic and it is coming from, so they will be talking about source IP and they will be talking about destination IP. So not exactly IP also. So they might be talking about networks also. So that might be the case. So like, okay, we are just getting connected with one network to another. So when all these networks would connect with each other, that is called the overall bigger picture of the internet. So let's get into some sort of IP addressing now. Anyone of you have heard IPv4? What is
Yes, ma'am.
IPv4?
Yes, ma'am.
It is a Internet Protocol version 4. It is a 16.
How many, why do we need an IP? An IP is needed. Anyone on, right now I'm using my laptop, you guys are on your laptop. So what is common between all of us? We are having one IP associated with us. How you can check your IP? You can simply go to CLI and then you can run the command IP
Config all.
Yeah, maybe you can go for /all also. It would work. Even if you simple type IP config, that would also work. Okay. So that's brilliant, right? So now the thing is, let's say an IP could look like this: 172.16.0.1 slash maybe 16. This is the one example of one IP. IP means it is not ending with 00. So nothing is called 00. Now let's assume I draw one bucket. Let's say I have a bucket. Okay, not very good bucket, but let's try. So this bucket is having some sort of, few very small balls inside. So now if I name this bucket as, like, this is the ball, okay, let's say gaming balls. So that means this is somewhere where you have to actually come and pick all the balls. Now, if I'm looking for a particular ball, now you have to come and let's say I'm looking for this ball, pick it. Now, if you want this one, then you have to pick it. Similarly, you have these particular balls are your IPs. And this whole chunk, this whole bucket, it is a collection of those IPs. So it is called a network. So network would represent as overall. So for example, in our homes, we live in a house, but individually we do have some our own identifications also. So that is the house number, whatever, but in house number, what is your ID or identification? That is different thing. So network, for example, another example we can take. So this is CCNA batch, right? So if I have to identify each of you, so I can make like CCNA, Shagun, and this is the beginner's batch. Then in anyone, let's say Gautam, if I have to assign him the first ID, I will go for 01, or maybe I can go for by his name also. This is what we can, we human beings would be actually understanding. So now, rather than going for this one, let me go for 01. Same thing will be common to all of you. For example, this is first person who is in the batch. This is the second person. This is the third person. Now, what is common between all? They belong to the same batch. All of you are actually the part of the same batch. So this tag will be common to all of you. When you, it is just like an ID card. Whatever, if you are belonging to the same college or same university, maybe same company. So something will be common between you. Only your employee ID will be differ. So that is the overall idea of your IP address also. So in IP address, there are two things. One is called your which network it is belonging to, and what from in that network, whatever, wherever this person is residing, that is called your IP address. So let's assume it is having two things in it. One is called its network ID. So the network information is called net ID or network ID.
And host
And
ID, second one is.
And another one is called your host ID. Host ID means from that network where this host is actually locatable, how you would identify. For example, if I'll say come to my Zoom session, and then under my Zoom session there is someone who's called Akshay. So that means first of all, anyone who wants to reach to Akshay, then first of all they have to reach to my group, that is my Zoom. So for whenever any person is generating any traffic over the internet, so that means first of all, we have to assume that person is belonging to a particular network. That no matter, maybe in a particular network, you might be the only one. It is possible. There can be a network where only single user is there. But for sure, you will always be a part of the network. So anyone from the internet, whosoever wants to talk to you, first of all, they will find you. Find you how? First of all, they will come over here. Then from here to here. And now, if I show you the Zoom and the bigger picture, let's say this is the PC they have find out, right? For example, this is the network, the same network, I would say this belonging to the network of 172.16.00. Let's say that is the network. And let me represent that network over here, 172.16.0.0. This is the network. In that network, this PC is having 172.16.0.1 as the ID. So that is the overall idea. So this is the shift number 1. Shift number 2, what will be the shift number 3? Shift number 3 will be, let's say, in my PC, or maybe anyone who wants to talk to Akshay. In Akshay's PC, there are multiple other applications and other web traffic is going on. How somebody would identify where is the Zoom? So these small bubbles are representing the different applications that are currently running on the device. So maybe out of them, let's say this is the Zoom. So third shift will be from inside PC only to identify which is the exact application the person is actually looking forward for. So these are the three kind of data. So first of all, network search will happen. It is called network search. Second search will happen, host search. And third search is application or port number, we call it. Every application is given with a unique numerical number. So we call it port number. So maybe if you are on Zoom, that we might be having a different port number. If you are having some sort of, let's say Snapchat or maybe WhatsApp or whatever, so that will be having a different port number. Microsoft Word, different port number. Media player, different port number. So every application is basically identified by the help of a port number. So port number is basically a numerical number. So this port number ranges from 0 to 65535. So this is the range. any port number can be lying between this range. So there is a rule. So we have some sort of well-defined port numbers. So these port numbers are coming from 1 to 1023. So these are the port numbers. So, and another one thing is these port numbers are always recognizable over the internet. That means if I'm trying to open HTTPS blah 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 something, then that means that is there is a standard port number. So my destination port number would be identified
44.
as 443. So if you are searching anything with the help of HTTP only, but not without secure shell, it will be port number 80. So like that, there are other port numbers. I'm not going into that kind of particular detail now. So let's stick with the IP topic now, because we have to cover the IP addressing today. So let's say now how this IP will come into picture, how your PC will understand, okay, I have to behave like this only, like I have to tell anyone like I'm the M172.16.0.1. Now let's get back to the track. When you actually, we all have our systems, we all have our laptop, mobiles and all. So what is there, how you connect to your laptop or how you connect to your mobile? So there is a port, right, where you put some sort of charger, or maybe you have some data cables also. Before few years, when we used to buy the phone, we got to have those data cables also. That was a part of the mobile accessories whenever you buy them. Now these data cables are itself the part, they are just simply being called as your charger also, because they are simply given with one extra adapter. So let's say this data cable, you are connecting with this data cable, and this is, let's say you are connecting with your, you want to transfer your whole data from your phone to, so the transition is you just want to send the data from phone to laptop. So now you know very well there is a connector where you have to plug this cable very well, you know, on the phone also and on the laptop also, because you can see the USB connector also. Most of us, we know very well what is a USB connector. So, but same case, whatever you will be dealing with the devices, for example, router, or maybe you are dealing with a switch, or maybe you are dealing with a firewall, whatever the devices you are actually dealing with, these are connected to the wire through nothing but there are some interfaces. We know where we have to plug all these cables are. So these interfaces, so every interface is actually the part of your network interface card. So in short terms, I can say number of interfaces are equal to the number of NIC, network interface cards are. Okay, so that means if I have a router that is having 6 interfaces, that means how many network interface cards I have?
6.
6, right? Yeah, exactly. If I have a switch where I have 24 ports, that means I can attach or I can connect 24 machines over the switch. So how many network interface cards I do have? 24. So your number of...
Ma'am, excuse me, ma'am.
Yeah.
As in switcher, in case of router, there are also console ports there. So they are also considered as a NIC.
Okay. Console port is basically, it will be for your user accessibility purpose, so that you can take the configuration control, graphical or user interface. Right now, we cannot go into it. It is like will be a kind of high level stuff. So, okay. So let's say we are talking about this connection of LAN cable, how to form a local area network, or how you will be connecting these all devices with each other. So first of all, you have to find out this interface where you will be connecting your device. Okay. So now let's say number of interfaces, we already know it is number of equal to the number of NICs. And there is a rule, if it is on the NIC, I mean on the router or on any other device. So there is a rule, no two interfaces can be configured
with the same IP.
With the same IP. That means same network भी नहीं होना चाहिए, no same network. right?
Same
So
same network तो हो सकता है मैम.
no, not that will be network overlapping. So that will be the issue of network overlapping. You cannot have an network interface card. I mean, two interfaces cannot be having the same IP. So we can conclude if I have 4 interface, that means this interface will be having network 1, this will be having network 2, and this one will be having network 3, and this one will be having network 4. That is the overall idea. So that means if you have a company where you have 3 or 4 departments, you can just go for different, you can divide them for the security purpose. You can just divide them into 4 different networks. So, but it will be on the same device, just like your router only. So it will be on the same.
Hello, ma'am. Hello.
Yes.
Ma'am, I just want to clarify that one, if you are saying that IP address is 172.16.0.1/16, that 16 belongs to what exactly? I just want to.
Yeah. We are going on to that way. We are on the very zero level of going. Yeah, we are on the journey to reach there only.
Okay.
Yeah, don't worry. So now second thing is this network. Now we just before few minutes we said every IP is having 2 parts. One is called net ID, another one is called your host ID. Host ID. So we have every IP address. It is of 32 bits. 32 bits.
Ma'am, we are not covering OSI model in detail today.
No, we will be covering layer by layer. For example, when we will be covering routing, we will be covering network layer. When we will be covering your port address translation and port numbers layer 4, which is your transport layer. Every layer.
Okay, we will be covering OSI model with the other topics.
Topics, yes.
By layer.
Yeah. So now let's say if I have to type the IP, let's say now that let's change the IP 10.001. So what will be, is it looking like 32 digits or what do you understand why it is 32 bits? These are, if you calculate how many bits we do have.
Each octet is like 8 bits.
8
4
after that
4
0.
octet of 8 bits each.
8 bits.
Okay. So let's say some people, because they when they join in the very beginning stage, some people just they count like this. Okay, 1, 2, 3, 4, 5, 6, and 7 maximum. These are the 7 digits. But why
This
they
is
are
a class AIP, right?
Yeah, that is class A. But now let's say how to actually work on these 32 bits. So IPv4 is basically having 4 octets. What is an octet now?
Convert it into binary.
Yeah. So there is a number system. So if
Octet
I
means 8 bits.
Yeah.
8 bits.
Yep.
Let's 0 1 0.
Let's say we are talking about any INR or maybe USD or whatever. If we talk about any currency, if I say I have $100 or 100 rupees, so you will understand like 100 is mentioned in India like this also, and in US also. Everywhere 100 means numerical value is this only. All over the world, we human beings, we follow the same number system. So maybe what I'm trying to say, 100 we do not type like this, and somewhere else in the country they type like this. It is not possible. 100 means 100 only, like this. This is the way how we type 100. So why the reason is, we all human beings, we follow the same common number system. It is called decimal number system. In decimal number system, every number system, it has some sort of identificational characteristics. Number one, every number system will be having some symbols. So what kind of symbols? For example, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I have to type 1 lakh or 1 million, again I have to repeat one of these other combination of 2 symbols only. So we normally call it digit or a symbol. So how many symbols we are totally having now?
10. 0 to 9.
Yeah, 0 to 9. So that means
10.
so total
Not
we do have
10 now.
Yeah, total we do have 10 symbols. 10 means deci. in Greek letters, these are the symbols actually, how the number system actually named after them. So 10 means deci. So that means decimal number system. So because we are having 10 fingers also, 10, so that is the reason why human beings are so common with 10 as the number system. So now if I have, let's say now that means any number system, what will be the name of that number system? That would be very highly dependent upon how many digits you are having. So if you have one symbol only, it will be called just as the digit only. There is no symbol. It could be any symbol, maybe star. So how you will represent anything with star? If you have to say one star. If you have to say two star. Similarly, three, like this. This can be also one of the number system. This star can be replaced by any other symbol in the world. This can be one digit number system. Now, if you have two symbols, two means called bi. Anything we call it like bi-directional, right? Bi-directional means two. Bi means two only. So that means if you have number of, sorry, if you have number of symbols are 2.
Hey, Vishal, yeah. Okay. I'm about to.
Okay. So if the number of symbols is equal to 2, that means now we are talking about the binary number system. So bi means 2. Now what are the number system? What are those symbols that we are using? It is 0 and 1 only. That's all. Whole of our digital world, they are actually just the building block for whole the information, whatever is going on right now in the world, that is based upon 0 and 1. So that
0
is
and 1.
yeah, surprisingly. So whatever we are doing on the Zoom, again 0 1. I'm talking anything to all of you, you are listening me, 0 1. Now we will be able to see how this 0 1 is actually turning into the point. So now let's say binary means this one. But here in binary, we have some sort of magical stuff is going on. So now if I say in decimal number system, if I have to type 1890, so that means how will I type? First of all, we know very well, something is called ones place. Yes, all of you agree with me?
Yes.
Then we have
Can I please come again, ma'am?
Yeah, it is the mathematical way how we type this tens place, hundreds place, and then we call it thousand place.
Yes.
Yes.
Remember?
Yes.
That is
Yeah,
just,
ma'am. Definitely.
yeah, that is just from our school days. Okay. So now the idea is it depends upon the value, and that is the way how you will actually go for it. So if you need only 890 to represent, you don't need this this thousands place at all. So that means the number of places will be reduced. So now it is a 4-digit number. If you have to type a 3-digit number, you can just go for accordingly how many actually spaces or the digits you need, right? Okay, so now that means I have to type something like this: 10 raised to power 3, and over here it is 10 exponent 2. This is 10 exponent, the last value is 10 exponent 1, and the last value is 10 exponent 0. So anything raised to power 0 is 1 only, always. So same thing, now you have to repeat the same thing. So stick with the logic. This is the base. That means that is the total number of symbols. If you are talking about learning the binary number system, if you have 1 bit, let's say we have only 1 bit. That means just one bit. Now you are going with the least. Okay, so this one is called, there are the value, like it is this is the increasing order. So the value would increase from right to left side.
Right to left.
Okay, so the right hand side, we have a special name for that. It is called most significant bit, and the increasing ordered line would be called
Least significant.
This is called least one. Sorry. I'm wrong over here. Least means the smallest one.
Yeah.
So this is called least significant bit, and this one is called your most significant bit. Okay, so that means you would understand. So that's what we were talking about. So in this way, you would understand this is 100, this is not 100. Okay, so if you will be mentioning, okay, this is, if you will be changing the order of LSB to MSB, then the values will also be changed. Make sure always. Okay, so let's say I have one bit only. In 2-digit, in binary number system, I have only 1 digit. So either that digit can be, first of all, what will be, we will start with always the first place only. So that means 2 exponent 0. So now I have only a single digit. So that is my only place. This digit can be either 0 or it can be 1. So how many combination we can have? So let's say I have, either I can represent 0 or I can represent value as 1. Can I represent 2 with the 1-bit representation? Yes or no?
No, ma'am.
No, right? We cannot
No,
actually represent. So now, ironically, now let's say I have 2 spaces now. One space is this and one space is this. Let me just zoom it out. I'm not too sure whether it will be getting done or not. Okay, fine. Not getting. So I have 2 places now. Over these, there are 2 places. Again, you have to start the same thing. So this is your start from the right hand side. It is 2 exponent 0 and other one is 2 exponent 1. This is important always. So what will be the final value when you will calculate it? It will be calculated as
3.
1.
1.
And it will be calculated as 2 raised
2.
power 1.
2.
2.
Okay, so that means now I have 2 places. One is this one,
Just with the one.
this one, and this one. So now let's say how these places can be filled. So I can have either both sides 0. This one is also 0, this one is also 0. Maybe this guy may be turning 1 and this one also be turning into 1. This is 2 very easy combinations that you can see in 2-digit number. Let's say now this guy is 0 and this is 1. But the value is different. You can create many combinations until and unless they are not getting repeated. They are in the unique order. So now let's say this is 1 and this is 0. Now can you come up with the 5th combination in this one? No, right? If you will be making any combination, it will be simply nothing but the repetition of the previous one. So that means now here is a pattern. If you have 1 bit, you can go for 2 combination. If you have 2 bit, you can go for 4 combination. Now let's check with your 3-bit stuff.
Sorry, ma'am, but I'm not understanding this mathematical stuff, binary thing.
Binary,
entire
it's okay.
thing.
Okay,
Ma'am,
okay.
but it is
Even I'm-
required for our CCNA. CCNA is required.
And can you please keep this this thing and can we proceed for the subnetting?
Sir, subnetting is only, I mean, somebody can only understand subnetting if they are very comfortable with these bits.
Okay,
Ma'am,
ma'am. You can
even
continue.
I'm
Ma'am. You can
feeling
Yeah.
continue.
sleepy with this
Subnetting,
mathematical stuff.
no. It is not mathematically, don't worry. You are just thinking maybe like in that way. So see,
So
we everyone knows,
subnetting it is a very important part for
yeah.
CCNA.
So
IP
this is
addressing
the
and subnet.
base. Yeah.
If we
So that
if we
is the
if
base.
we if we don't clear that, so we will not do it.
Yep.
This is the most important part.
So this is the most important part, guys. And don't worry, Akshay. This is, I mean, just a basic thing you are, because maybe you are thinking like it is a mathematical. No, it is just, we all know, like, let's say you are shopping for something 1,290 rupees. So we know like it is like 1,000 plus, what is the actual value for this? Plus 200
200 plus
plus
90.
90. So this is what the value we know. And this is what we are actually breaking down everything. Nothing else. There's no mathematical high rocket science. Okay. So now get back to the main point. I have now let's say we have done with 1 digit and 2-bit representation. Let's go for 3-bit representation now. So when you go for 1's place, 10's place, 100's place, and 1000 place, similarly now go for in the binary number system also.
Please mute.
It's okay, Ashwini. Yeah, please keep just put yourself on mute. So the first value always, Akshay, for the time being, yeah, just cram these things. Later on, you will be getting used to nothing. It's no more difficult task for you.
Please ask me questions so that I can.
Yeah. I will be sharing one workbook with all of you. It is not even a single practice question. There will be 80-90 practice questions that I will be giving you in the weekend. So when Monday you will be coming back, you will be coming up with so many solutions.
Thank you so much, ma'am. Taking so much support for.
So why I'm doing this? Any idea? So how many places now you can see? Each one will be 1 place value. So now you have to calculate the respective value first of all. 2 raised to power 2 is 4. 2 raised to power 1 is 2. And 2 raised to power 0. Anything raised to power 1 billion raised to power 0 is 1 only.
1.
Okay.
What is this raise part, ma'am? It is multiple or?
This is like we are starting in binary number system. How many places, I mean, how many digits you are, or the how many, you can say the spaces you are using to represent any number, that will be starting from 0 to the further proceeding value. For example, if anyone is saying write in binary in 3-bit, give me the code for 3. So you have to have these, like you will be drawing 3. First of all, let's say I have 3 spaces like this. Okay. So now you have to give, that guy is asking you, use these 3 places and give me the binary code for number 3. So this is what we are calculating, how you will be confirming what will be the final code for binary number 3. So over here, so the value will be starting the first place, whatever we call it from the right hand side, we will be starting with always 2 raised to power 0 only. That is not just new, that is from last trillion million years. So for example, in our number system, decimal number system also, we call it 10 raised to power 0 when we type anything. So then we go with the, like this only. Whatever the base value is, now you have to exponent it with the increasing order. So you just keep going until and unless you are not reaching the final digit, I mean final place. Okay, over here, this is not 1, this is 2. Okay. What will be the final value? If I have to type over here, so it will be 4.
4.
It will be 2. And it will be 1.
1.
Right? Now the idea is, whatever the binary code you will be generating, there are some other very long formulas also. We don't need to go into it. So go for the tricky, I mean the smartest way. Whatever you are going to type, for example, number 3, you have to look at these values, whatever you are now calculated, 4 to 1. Then you have to just place tick. Let's say we are going to tick those values whose sum will be equal to the desired amount. So if it is number 3, what will be the value that I have to tick right now? How the sum will be actually ending at number 3.
Power 0 will be 1,
So
2 to power 1 will be 2, and 2 to power 2 will be
2
0.
to power, ma'am, we can go with 2 to power n and with the value which is starting from 0 to 0, 1, 2, and this
yeah,
way.
that will be much
0
more
to 8.
confusion thing. So it's okay. So, but for the people who are actually some sort of good in representation of these things, it's okay. But now for the time being, just let's play 5 minutes this quiz. If I have to say you have to type number 5, just tell me those ticks where it will sum as number 5. Which number I have to tick?
Number 3 and number
2 raised to
4 and
Number
2
4,
and 2 raised to
and
0.
Number
one.
4 and 1.
that is all, right? Now, if I have to type number, let's say 6, what will happen?
4
I
plus
have
2.
to we have to own the bit of second and third number.
That's all right. So now let's say how the binary system would work. This code is actually represented as, for example, there we did not tick, where the value is not participating in the calculation of any digit, that will be treated as a 0. Wherever you are considering that digit,
That will be
that
1.
will be 1. Fine. So now let's say this value you can see 3 in decimal number system. Let's say 3 in, if I say, if the base is 10, it will be equal to, what will be the code for 3? 0, 1, 1 in base 2. So that is the overall idea. Even if you just remove this base thing, it will be easy for you just to calculate these things. Now, what will be the this value? This is 4 plus 1, 5. So that is 5. How you write 5 in binary? 1, 0, 1.
1, 0.
0, 1.
Fine? Yes.
Yes.
What will be the value of 6? It is
1, 1, 0.
exactly correct. So now let's type everything. We have to now understand what will be the significance of those places. So now what will be the maximum thing can happen? Maximum thing will happen when all these things are ticked together. Okay, so everything is 1. This is okay, this is also there, this is also there. So what will be the total sum?
7.
7.
7.
Okay, so that means all 1, 1, 1. So now here is a pattern, something we have to know. Whenever you do have some sort of, let's say this was a 3-digit representation. Talk about 2-bit representation. If I have 2 bits, 1 bit over here and 1 bit over here, logic will always be the same. This is going to be your 2 raised to power 0, which is 1. Now I'm going to remove that 2 raised to power 0 just for matter of removing the confusion. So it will be 2. Why? How I calculated this? 2 raised to power 0. This is 2 raised to power 1.
1.
So if you don't know how did I come up with over here, this is this. Okay, right. So now what will be the value? If I have to type 3, can I type number 3 over here? In this one, can I type number 3? Can I have the code for 3?
1 1 1
Yeah,
1.
1, 1.
Both are 1 1. If I have to type 1, then
0, 1.
Only
this one only.
1, 1. Yeah.
0, 1.
Yeah.
Yeah. So that means this guy is not turned on. Okay. What will be number 2?
1,
1,
0.
0.
1,
This
0.
one
2 raised to power 1.
and this. And what will be 0 0 now?
0, 0.
0, 0.
So I mean, what will be the value of? Yeah, I gave the answer only.
0, 0.
My question was, what will be the code for 0? So this is 0. This is 0.
0.
So now let's again convert them to binary. So if I have to type 3, that is equal to 1 1.
1, 1.
If I have to type 1, that is equal to
0,
0
1.
1.
0, 1.
If I have
0.
to type 2, that is
1,
equal
0.
1,
to
0.
1,
1,
0.
0.
1 0. So if I'm coming up with number 0, that is equal to both are 0.
0, 0.
So you can blindly have one rule. Whenever, no matter how many digits you are, how many actually bit representation you are using, this is called 2-bit representation. If you will be using the 3-bit representation, there will be a third place coming into picture, and it will be called as number. Here the place value will be number 4,
Yeah.
and
2
here it
exponent
will
2.
be 2 exponent 2. This is how you would calculate. So this guy will be keep on expanding. So it will be starting up with 0. So you started with 0 and 1 and 2. So now, so whenever you are going for the number of bits, you have to, check there is one pattern. So in binary number system, everything is so beautifully, you can say the magically there is everything, there is a pattern.
So
So
what is the answer of it for the representation, 3-bit representation?
3-bit representation, for example, if you will be using right now from here, if I have to type number 3 in 3-bit representation, that is the code. This is the code. Remember, this is the code where you have to include the 0 also, because you have to tell whether this guy is up or not. So this is the, you have to tell what is happening with the 3rd bit also. So everywhere it will be off. So you now in 3-bit representation, these new codes will be, tell me the new code for everyone. In 3-bit representation, what will be the new code?
Add
0 1 1
0 1 1.
1 1.
And what will be 1?
0 0 1
0 0 1.
0
Exactly.
0
And
1
0 1 0.
0 1 0
0 1 0. And
0
what will
0
be this
0
one?
0.
000.
Yeah. So wherever 0, no matter how many bits are using, just blindly put 0, all the bits. Right? So now this is the difference between 2-bit representation and 3-bit representation. This is not the only difference. Now the problem is in 2-bit representation, consider this part now only, just this part. So now in 2-bit representation, let's say what was the minimum value that you have actually covered. So that was 0. And then you had 1 also, 2 also, 3 also. Can you convert value number 4 in 2-bit representation? Is there any possibility you can type 4?
No.
Right? So if you have now, just follow me. So you have to take care of the base. Then you have to remember how many you have to exponent the number of bits. Number of bits representation you are using right now. So you have to exponent those bits, then you will be getting the total range. Now you have to simply fill these values into this, whatever the formula I have written over here. So base is 2, we know binary base is 2 only.
2.
Okay, so I have 2 and I have to exponent it, let's say following those brackets and all. So I have to exponent value. How many number bits I'm using right now? 2 at the moment. Let's say. So 2 raised to power 2 is 4. So these are the 4 combinations. But now because this 4 is also including 0 also, so it will be starting from 0, 1, 2 and 3. So that means the last value, the maximum value that any bit can actually give you, that will be 1 less than the total full range always. If you have total 3 combination, I mean 3-bit representation, so it will be 2 raised to power 3. Okay, so that will give me total 8 combination. But now if you will see, if I'll put everything on now, if I'll put everywhere 0, 1 here, if I on all these bits,
maximum it will give 7 outputs.
So maximum will be 7. So here is a pattern. So if it is number of bits are 2, it will be maximum number will be 1 less than 4. That means 1 less than whatever the number of bits you are using for the representation. This is important to understand because this is not just something to understand. These are the shortcuts also, and this is the smart work also. So that you should not confuse. If I'm giving you 8-bit representation and I'm giving you the number 12, please represent it in, 3-bit representation, and I'm giving you, please give me the code for number 12. You should not think twice. You should simply say, no, it is not possible.
Not possible.
Because 2 raised to power 3, 3 bits can only give you the maximum number as number 7, not more than that, not even 8. If you have to type 8, how many numbers is, how many bits you need now?
4.
Yeah. So now I'm going to give you some number. You have to give me how many bits you need for those. Okay, all of you. I have to represent number 17. So how many number of bits I need?
9 bits.
5.
Why?
4 bits.
5 ma'am.
Okay,
5 bits.
2 to
Five.
power 4 it will go to 16 only, and after
5.
that we
It's
will
5
need
bits. 5
17.
bits. We need 5 bits.
Let's check. So I'm going to type those place values over here. You can work on those.
9 bits.
2 raised to power 0, 1, 2, whatever it will be. 2 raised to power 0. Over here, 2 raised to power 1. It will be systematically if anyone is getting confused, because this is one of the confusing topic in CCNA.
Yes, definitely it is.
If you will be thinking it is, but people who are enjoying this conversion, ask them how good it is. Seriously.
I already slept for 5 minutes.
If anyone completed his engineering, then he can enjoy.
No. It will be, I have other batch, and there I have a girl, she's from law, this degree background. Still, she is like breaking the ankles of everyone when it comes to binary and subnetting questions. Really good.
But you are teaching very good as comparing
Ma'am,
our
I think
college
you are from
teacher.
mathematical background.
No, I'm from CSC. Okay. So now I have to type number 17. So let's assume we will be typing the total value also, 16. And this is 8.
0.
8.
And 4. Okay, one thing is, you have, if you type from the right to left, you will double everything. Okay, just like this.
Yeah.
If you are typing from right to
left.
Right,
Forward.
Okay, let me
Right
draw.
to left.
I'm not very good. I'm not even a good driver also. So if you are typing from left to right, okay, you are always dividing the every bit in the next chunk. But if you are typing from right to left order, you are doubling them. Remember always, okay? These directions would matter a lot. So now I have to type number 17. So first of all, I have these many digits, these many bits. How many bit of representation I'm using right now?
5.
5 bits.
5.
You have to count these things. Do not get confused with the last thing, because it will always be starting with 0. So it is like ending with 1 less than the total number of bits. So 1, 2, 3, 4, 5. 5-bit representation you are using right now. Now, can you give me, with 5-bit representation, what will be the minimum value and what will be the maximum value?
0 is the minimum value, and maximum value is 30.
Okay.
33.
Now repeat the question.
Wait.
31.
This is nice.
31.
Somebody said 30. Another one said 33. Yeah.
31 is the maximum.
Ma'am, repeat the question.
Maximum value that you can be represent in decimal with the help of 5-bit binary representation. What will be the maximum?
31.
Yeah, fine. Okay.
32 we can do, ma'am. From 0 to 31, it will be maximum is 32.
Yes. So
but
the
we can
idea is
do for
total
till
32
31 only.
combinations. So total will be 32 combinations, and it will be starting from 0 to 31. So how we calculated those 32? Akshay, this is for you. Special 2 raised to power number of bits we are using, which is 5. So that is 32. So that means now you have to keep track of your binary number system base and how many bits you are going to represent them. That will give you total combinations. Now from those total combinations, I will be starting from 0 to 1 less than the total combination. That means 0 to 31. That is the range. This is how you have to understand.
Network ID range.
Not.
No, how we calculated this?
So simply you have to take the binary base value, that is number 2, and then you have to calculate how many bits you are using. 1, 2, 3, 4, and 5. So that means you are having 5 places where you will be putting either 0 or 1 at a single time. And each combination will give you a new value. So that value can be either any one between, it's like if you will draw one circle. So, and if you will be doing any random combination of these things like 0, 0, 1, 1, 0, whatever. So any 5-bit random combination, either it will be ending at 0, 1, 2, 3, whatever, all the way to 31. So it will not cross anything. So all the values are between this range. That is what I'm.
Maximum number of combinations is 32 and maximum
32.
value is 31.
32 because 000 is the first combination and 31 will be the last combination. Now one more time to go for one more trick. So now we said 32 and 31 something. Now do you know 31 will be all values will be 1. Okay. Now again give your ears everyone, listen to me carefully. Next value we know it will be the doubling of your 16. That is already we know 32 only.
32.
Next bit if you will be using, okay, if you will have to represent any value that is crossing 31, maybe 32 itself only, 33, 34, 34, I mean 35, anything. So that means you have to add one more place over there. You can say I need one more bit for that. And now if you will always be having, there is one more stuff you have to know. For example, this is 1. If you are using only 1 bit, total maximum values we already know it is 1. But if you are having 2 bits, so total combinations are 4, and we know the next value is also 4, and the sum will be, if the maximum sum that you can, if the you will be adding them all together, it will be 1 less than the next value. So now what I'm trying to say, if the next from the 4 only, if the next value is 8, if all of them if I'll be adding together, it will sum up to 7.
Maximum value is 7.
Ashwini, very good, very quick. So this one next value will be, it will be, what will be the total sum? 15. This will, and what will be from here? Just put your counter, put your pointer from. This is from value. So where exactly at present you are. So if you are having this bit and you are looking forward for the value of 31, simply you know next value is 32 and I have to put all the values as 1 only. That will be giving me the 31.
Yeah, 31.
So that is like chunk by chunk, you have to understand every single thing now. This class is going to be the super important class for people who will be doing really good in IP addressing and subnetting later on, troubleshooting in IP routing, netting, ACL, everything is that is the building block for your CCNA. Okay. Okay. So now let's say this is 5-bit representation. So let's, I think now you do have some idea. And let's practice for some reason, and after that we will go for some sort of IP addressing. Now I say I do have 32-bit IP address. Tell me how many addresses, how many combinations I can have, different combination I can have from 32-bit.
31.
Don't be very quick. No.
255.
No. Okay, sorry.
Can you repeat the question once?
Yeah. That was a heavy question. Okay, we start with the baby steps. Leave it. Ignore this. Now I'm saying with the 1-bit representation, how many total combinations you can have? So there is a
one.
Yeah. I'm just going to help her thing for you. You have to always remember number of bits, whatever you are using right now. So,
with 1 bit it's only 1.
2. 1 bit it is 2.
Okay, and if I'm using 2 bits, if I'm having 2 bits, how many combinations?
4.
Good. 3 combinations, 3 bits. I mean, how many combinations? 8. 4 bits. How many combinations?
16.
Okay. Now you got the point. Now I'm saying 32 bits. How many combinations?
164.
Power 32.
2 raised to power 32. It is in billions, not even hundreds. It is in billions.
Billion.
Billion, ma'am.
2 raised to power 32. I even don't know the exact number, but it is in billions.
Yes, ma'am.
Right? How it is will be billions, because see, one, when you will be calculating, you are doubling, you are exponenting everything like super speed. So when it will be, what will be the value of 2 raised to power 7? I mean 2 raised to power 5. How many combinations?
32.
If you will keep on going like this,
64.
So now you will give me the random value. What will be the 2 raised to power 10? Okay, one value
1024.
is important over here.
128.
1024, ma'am.
2 raised to power 7 is 128. 2 raised to power 8 is 256. And now this is your 2 raised to power 10. So 2 raised to power 10 means whatever the value you have, 2 raised to power 9,
1024.
512, and 2 raised to power, yes, very good.
1024.
1024.
That is the final value you will be having. Akshay, yes or no?
Yes.
Okay.
This is called 1 MB is equal to 1 GB. Right.
Yes, that we will be definitely doing. So 1024 in normal, if I say today I bought 1 kg rice, how we say 1 kg?
100 grams.
1000 grams.
1000
1000 grams.
Oh, sorry.
1000 grams.
Yeah, in this quiz, ladies will be the बिल्कुल जो कहते हैं ना कि they will be the correct one. So it is like 1000 grams. Okay. Then similarly in binary number system, we have something called, first of all, we will learn the combination. If we have total 4-bit representation, we have any 4-bit combination. It can be anything, 001, 0010, 1100, anything. So that is 4-bit as the combination only. Together, group of 4-bit, it is called nibble. Okay. So if you have total 8 bits, 1, 2, 3, let me space them. 2, 3, 4, 5, 6, 7, and 8. Collection of 8 bits, it is called 1 byte. Okay. And if you have value that is crossing 2 raised to power 10, or it is starting from 2 raised to power 10 only, so it is called 1 kilobit. And if you are having another one, let's say bits only right now, otherwise you will be getting very confused. Fine. So this is called 1 kilobit because it will be coming under the 100, that is kilogram now thing is coming. But now if you are having doubling it, so it is called 2 raised to power 20. I mean not 20, 2 raised to power 11 only. That is called 1 megabit. 2 raised to power 12, it is 1 gigabit. Good.
Gigabit.
2 raised to power 13.
Tetrabit.
Tetrabyte.
Yeah, tetra.
Tetra or tera?
Terabyte.
Terabyte.
Tetra pack, it is a milk packing.
Yep.
Okay. So
Then
now,
tetra is
don't worry. So we will not be going into it too much. It's okay. But yes, you have to simply remember mega means doubling the kilo thing and all. It's okay. Right now, you will be given too much chances to learning these all. So this is okay. Now come back to those 32 bits. That this is what my aim is today. I have 32-bit IP address. So every IP address would actually be typed as like 20.20.30, let's say .1. Okay. Out of those billions combinations, this is one of them. You can assume like this. Okay. So that means whatever the 2 raised to power 32 combinations you are having, this is just one of them. Now we are having 32 bits. That means we are having 4 octets. So in IP addressing, we have divided all the IP address of 32 bits into 8 bits in a group of 4. I mean, group of 8 bits in 4 divisions.
4 divisions.
So that is the reason why it is also called IPv4. 4 stands for these 4 octets, right? So this one particular, this division, I'm talking about this one, and similarly this one, and this one individually, each one is called octet. Okay. So now in each octet, how many bits we are having? We know very well. We have 8 bits. So 8 is here. It is just nothing, but we have divided those 32 into 8. And will it be always 8 only? Yes, answer is always 8. You cannot transfer one bit to another. No. It will be always 8 bit. What 8 bit? 8 bit representation. This is what exactly you have learned before few minutes. So that means whatever you will be typing, now you have to simply know. It will be very easy to understand. This 20, 20, 31, everything is mentioned in 8-bit representation respective with the respective octet. For example, this is this octet, this is this octet, this is that octet, and the last one belongs to the last octet. So now simply you have to give me the binary for in 8-bit representation. So this is my 8-bit representation. 1, 2, 3, 4, 5, 6, 7, and 8. First value is 20. So what will be the place value right now? So I'll be starting with, let's say from this side.
It's 1, it's 0, 0, 0, 0, 1, 0, 0, 0.
Wait. Okay, so let's say we will be starting from 2 raised to power 0. Same thing will happen. So we are going to go with 2 raised to power 0. And now next value we know very well, 2 raised to power 1. Just number of bits now you have to keep on exponenting. 2 raised to power 2. And 2 raised to power 3. Then you have to have 2 raised to power, then you have 2 raised to power 5. And next one is 2 raised to power 6. And what will be 2 raised to power 7? How many values now? 0 to 7
8.
total. Okay,
Yeah.
we have to stop now. So that means it will be looking like this.
Yeah.
Okay, so good to go with further. So repeat, imagine this is one octet and it will be exactly same. Format will be exactly same in each octet. First octet I'll solve for you. 3 octets you'll have to solve, all of you. Okay, so now over here I have to represent 20 now. Tell me the ticks where I have to put my ticks now.
0, 0, 0.
Okay.
0, 0, 0, 1,
It will
0,
starting
0,
from the
1,
left.
0.
16 and 4.
0, 0, 0.
128. Hold on. People are.
It will be 16 and 4 only.
Okay. 32.
2 raised to power 4 and 2 raised to power 2.
8.
I think that's
Okay. Don't worry. We'll go like this so that it can be very, very clear. 8, 4,
4, 2,
2,
1.
and 1. Okay. So now I have to represent 20. Where I have to put my ticks now you can see clearly.
16 and 4.
16
and 4.
Exactly.
Rest
So
over are
rest of the stuff will be 0.
0, 0.
Now it is like 0, 0, 0, 1, 0, 1, 0, and 0. So 20 is represented in 8-bit representation as 0, 0, 0, 1, 0, 1, 0, 0. That is the first octet value. Okay, so that is the first octet value. Same thing will happen with, because again it is 20, so same thing will be coming over here also. 20 over here. Now give me the value for 30. What will be the value for 30?
0, 0, 0.
842.
0,
It will be 16, 842.
Yeah. अक्षर समझ आई आपको?
0, 0, 1, 1, 1, 1, 0.
Okay. So that will be 16 and 20. Then plus
16,
more than
8,
will be 30. So rest of will be 0.
0.
So that is the binary of 30 now. You have to give me the binary of 30 now. So that is 0, 0, 0, 1, 1, 1, 1, then 0. That is the binary for your 30. So it will come over here. Okay. Now what will be the binary for your number 1? Pretty much
0, 0, 0, 0.
very, very easy. We go for the direct binary only. We know very well what we have to do. It will be 0, 0,
0, 0,
0, 0, 0, 0,
0.
how many zeros? 7 zeros, right? Followed by a 1.
Yeah.
So it is like 4. Yeah. So next one is 1. So that is the code for the last octet. That's all. So now if you will be actually, this value was, what was the 20th value? It was a 0, 0, 0, 1, 0, 1, 0, 0. So that was the first octet and second octet's value. Copying it and also pasting it over here. So now if we will calculate all these bits from first bit, second bit, third bit, all the way, so this will be our 32nd bit. So this is how IPv4 is called 32-bit, because we are using this dotted representation, 4 octet values, and each octet is having 8 bits in it. And all the bits are represented by those combination of 2 raised to power 0 to all the way to 2 raised to power 7. Now, few questions to all of you again. What will be the maximum and minimum value that each individual octet can have? Please tell me.
Maximum value 255.
Okay.
And minimum 0.
Okay, let's check now. So 2 raised to power
1 to 255.
I have how many bits now? Tell me. How many bits
8.
represent actually?
256.
Yes, it is like in each octet I'm representing 8 bits, right? So let's work on the basics that we have learned so far. So it will give me total 256 combination. Everyone is with me? Yes?
Yeah.
Okay. So now what will be the range? Range will be 0 to
0 to 255.
255, exactly.
Yeah.
So
This is
that
the
means
maximum value.
you cannot represent in the history of internet till date. You cannot have any IP where you can see 256 as the value. Reason is its range is itself at 255 only.
Yeah.
Right? So you cannot see any IP, or we do have something called subnet mask also. What is that? We will understand slowly. But you cannot have any octet that can be filled with 0 value as more than 255. It will be wrong. So maybe tomorrow or day after tomorrow, I'll be having one quiz for all of you. I can ask you this, please pick the valid IPs. And if you are picking any IP whose any octet is having 256 as the value, it will not be the right one because it is
Right
not
answer.
possible. Okay, so if I'm giving you, I do have a IP 23073. Now, this is not possible.
Invalid IP.
Yeah, 130, 73, 72, 73, this is possible. Anything
Easily.
from 0 to 255 is possible. So now that means, okay, now if you will again work on the basics, we know how this 255 would come into picture. So we know very well the maximum value is 128. If I present all these values, if I mark all of them as 11111, so that will be, because I know next value is 256 and the all one will be give me the 255 as the sum.
255.
Right? So that is some tricks and tags that you have to understand in binary representation. This is a very important class. Everyone please go through it. And now next onward, whatever we will be doing, it will be the higher and higher version of whatever we are now just learning. So if you are confused somewhere, please go through this recording one more time. You will understand what I'm talking about. I tried my best to go into the minute points of IP addressing today so that you should not be confused anywhere. Okay.
Okay,
So,
thank you.
Ma'am, when will be the recording classes will be available in the portal?
I think it is available after few hours.
No, yesterday class is not available till
Ma'am,
now.
it will actually, I think it will be available after 2 days.
Okay. So
So
yesterday.
if it is available on next day, then it will be really helpful for us to revision again.
Yeah. I'll talk to them. I mean to the IT team. And but by the way, if anyone is looking forward for yesterday's recording, it is already on the YouTube. Go to networking channel.
Okay.
There, that is under the live. There is CCNA live that is already done.
Ma'am, another thing, can you please tell once again interfaces? What is actually interface? That a little bit I didn't understand.
Okay, so interface will be, for example, let's say I have, you have TV at home?
Yeah.
Okay. where you plug your TV, we know like there are plugs and all.
Yeah.
So that is nothing but a kind of interface for your TV only, because we know
Okay.
this is a cable. Similarly, we have router, which is PC, where we are plugging the LAN cables now. In our case, there will be, yes, power supply is something different thing. But
Okay.
now because these all are the networking devices, we will be always using LAN
Network
cables.
cables.
So
Okay.
these LAN cables can only be plugged into a
Network card.
port
One interface.
interface. So that interface
Okay.
is called where you plug that cable. That is
Oh,
the
okay.
Yeah.
Thank you, ma'am.
So switch having multiple interfaces, right?
Yeah.
The difference of the categories of the LAN cables, ma'am. Can you explain
So-
further?
Yes, we will be covering. We will be covering what are the various LAN cables. For example, let's say,
Cross cable, straight cable.
okay. Just for example, right now, I'm giving you one motivation so that you can keep on, when you will be going home, you will at least understand. So let's say one cable can be used when we have to connect two routers only, or maybe two switches only, right? Or maybe two PC, whatever the PC is. That means we do have some scenario in life where we are connecting two similar type of devices, right? So it is like we are connecting two routers or two switches. Two switches and then two laptops
PCs.
or PC or devices. So this is different kind of cable that we will be using. I'm not going to
Crossover.
It's a cross cable.
Crossover cable.
Yeah.
Okay,
crossover.
yeah, we will be covering everything. Good.
When to use cross cable, when to use straight through cable.
Yeah.
Straight through for
And
the
Yeah, for different
devices.
systems.
And
The
another
different
one
system.
is, what if I'm talking,
RJ45.
what if I'm actually connecting this router with the switch, or with
Yes.
this switch with
We
this?
Straight.
we need a straight cable.
Straight through cable, ma'am.
So
Straight
now
through.
everyone who is listening in the session, that means depending upon the connection, if it is with similar devices or we are going to connect two different kind of devices, we need to have different cable. So we can have PC to PC connection, PC to router, router to switch. These are the three different connections that you can have. So similarly, in that way, we have three different kind of cables only. So I'm giving you one task, all of you. There are names. First one is called, number one is called crossover cable.
Crossover cable.
Crossover cable.
Second one is straight through.
Straight over.
Straight through.
And third one is? Third one is,
RJ45.
Console cable.
oh no. Third one is whatever is the name of the third cable?
USB.
No, there is a
No.
name.
The third cable is rollover.
Coaxial cable. Coaxial.
Very good. It is rollover.
Coaxial.
Oh, okay.
So this is task to all of you. Tomorrow before you coming to class, you should tell me the answer, which cable is used for what. So for example, in this topology, where I will use cross cable, where I will use straight through, and where I will go for the rollover. All of you. So this is your task. You can have.
How about, ma'am, in the crossover cable, what are the pins that is being used there?
Over here?
What are the pins that is being used in the crossover cable and the straight through cable?
Actually,
Yes. It will be like when you are having crossover, let's say there are some pin numbers. So there are, there
1
are
to 8.
8 pins in every cable. If you will open the cable, I'll run through that PPT. Actually, I'll have to show you the actual cables. So that means for pin number is 1, 2, 3, 4,
1 to 8.
5, 6, 7, and 8. This
Is there
is
any standard color coding for that?
yes.
Yeah.
Every single LAN cable will be color coded. Every single LAN cable. Okay.
Ma'am, I have one question, ma'am.
Yeah.
These classes are basic clearing class और Cisco का syllabus के हिसाब से start हो चुका है class में.
Yeah. Yes. So because we have started IP addressing, so it will be easy if we will go for the basic. So fundamentals, we should be totally having a strong grip. All right, so that was all about the IP addresses today. If you have any question, just do let me know. And tomorrow the agenda is you have to have number one, we will be understanding the IP classes. And what
Please,
is a
ma'am,
subnet
please
mask?
just let the management know that we need recording of the session
Sure,
after the
sure.
class, no?
I will let them know. I'll call.
Because I haven't clearly understood the topic of this because I'm a less understandable in mathematical stuff, so I just want to repeat it again, and I can just have my doubts clear in next class tomorrow.
I will say the IT team, and in case if you guys will be having any technical related queries, you always, I think you should reach directly to them. So sometime what happened back to back, maybe by 12 o'clock if we'll be having the next batch. So sometime I may skip that, but you always should not hesitate to reach out to the IT team. Even right now, this is the second class today only. Might be tomorrow you will be having some lab issues. Some devices are not working in the lab. So you should not wait for me, go directly to IT. Okay, so Pradeep sir is there, Gaurav sir is there, everyone is very willing to help you out. And from my side also, I'll be putting them into the notice, like you guys need those recordings.
Ma'am, can you please share the brochure that CCNA?
Yes, I think that brochure is still, maybe Gaurav sir shared with me. I'll ask them to put on the portal. Okay.
And ma'am, anything our group we have to ask in the question in that group, WhatsApp group for our batch.
There is a one group where we generally join for the doubt clearing and all sessions. Normally, every group they can also be some students can form their own groups also. You can it's all up to you.
Can you share please the link?
Okay, what you guys can do, any one of you can take the responsibility to form a group. Maybe you can
I'll
share.
just take the lead. I'll just create a group. And just you just share your ma'am WhatsApp number, ma'am. Like we can make a group on WhatsApp.
Or the other thing is, you guys, all of you can share your contact details or maybe your email IDs and everything.
Here, chat.
Yeah, no, not chat. I'm going to share my email ID. You guys can just mail me whatever your contact details are. I'll create one group.
Okay, fine. So can you please share this your email ID?
Yeah.
How about the ebook, ma'am? Is it possible to provide us an ebook?
Yes,
so
sir. Why not? Why not? Yeah,
so
yeah.
that we can follow step by steps your discussion, and at least before you can discuss us, so if you have the ebook, we can review it, and while you're discussing, at least we can follow easily.
Yes, there will be. I'll be sharing one guide that is related to this IP addressing, and there is one major link that normally I will be sharing with you. Go to some YouTube good channels if you want, and if you are very beginning at the beginning stage, then I won't say you should go for the random YouTube stuff. But otherwise, there are some topics which are very good mentioned in some quick guides. Cisco.com is the best tutorial point where you can actually go through and learn something. But again, point will be here in class, we will be going into the minute details. So after this class, if you will be learning the Cisco material, it will be very quickly understood by you. So that will be the overall idea. Okay.
Hello, ma'am.
Ma'am.
What will be your best suggestion people who are not from the networking domain? And in my case, I'm thinking to start my career after 10 years of gap. So what will be the best suggestion for me?
Yeah, I do understand because see, in every class, we never know people are going through what. So we should always start from the step number 0 only, so that it should be people who are already knowing. It will be a kind of building their more strong basics. People who are actually in the beginning stage, they will be learning from those strong basics only. So, and for you, Ashwini, I'll also mention you tomorrow 2-3 TCP/IP books also. So just whenever you get some time, go through them. And there is a quick guide from Cisco that I will be also forwarding to all of you. Just all of you mention one email to me and type CCNA batch as the subnet, not subnet, subject, and send it to me.
Ma'am, one question is
Email
there.
and our contact numbers, right, ma'am? We need to
Ma'am,
send it.
I'm trying to copy your email ID, but
It will not be copied. Sometime on Zoom you cannot copy. It will be copied everything.
No, but we have to share
copy
on
everything.
email.
You have to simply type it in somewhere notepad, like say st27180909@gmail.com.
Copy is not allowed.
Maybe sometime it happens. It happened to me also. When I come to Zoom and I want to copy something, either it will copy everything or nothing will be copied. It's sometimes it's a glitch on Zoom.
Ma'am, what we have to share on email?
You have to simply just say hello to me and say in the subject, please mention your batch, CCNA batch. That's all. Because there are other batches are also going on. For example, there are batches in the Palo Alto, so I should not get you confused with those all.
Ma'am, one question is there. Ma'am, can you suggest me some questions where I can find in YouTube for network administrator interview questions?
Okay. Gautam it is, right?
Yeah, ma'am.
Okay. Gautam, you have to mail me. I'll whatever I have, I'll send you the resources.
Okay, ma'am. I will
There
mail
are
you.
there are some entry level positions also. I'll be keep on posting you all of you.
Today I have got help from networking for some Atul sir video is there, no? So here the person has said me from support team, but I need to know that if there is more question related to the network administrator interview questions that can help me out in my interview. So can you suggest me that?
Okay, sure. I will be sending you the details. No problem.
Ma'am, one more thing.
One book is TCP/IP Illustrated Volume 1. Can I get the link so that
let
Atul
me
sir is
let me share the book only. I think I have that book, or let me just browse it.
the TCP/IP Illustrated Volume 1.
TCP/IP book.
Do you know about that book? So Atul sir is shared. There's we have to watch that videos that time is saying.
Atul sir is the CCNA is the top class. Thanks.
Can I ask to Atul sir to share with you?
Okay. There are some resources. I'll ask them, like whatever the resources you want. But do not worry if you will be following.
The reason is that book is very good to learning TCP/IP. So basic to advanced.
Okay. Let me try to send that TCP/IP book over here. And Ashwini, you can also go to it. This book is very huge, actually. It is more than 1,000 pages, so that's why I don't go for it. Otherwise, it is a good start.
Oh my God. So if it is you having another book, so please share with us.
Actually, I'm not a I never like reading books and all. But yeah, for my research purpose, I have to do. Otherwise, I'm not a very good reader. I always go for lab and practical things. Yes, Akshay?
Yeah, ma'am. I just want to ask that can we just know, can we get just prior notification what we are going to learn in today's class, like, so that we can prep a little bit. If today, if I would have know that we are going to learn this octets and all these things, so I would have done like a little bit preparation so that I can understand better. Whereas I'm just on a lower side.
Okay, sure. What I'll do, next time whenever is possible, you just whenever you will be, it will be matter of communication channelization. Now, whenever you will be grouping into one group, so I will also be posting there also. Second thing, whenever we will be ending the class, today we have ended the class and I'll mark you what we will learn tomorrow also. So that will also be the case. And sometime what happens, whatever the schedule I have, and people sometimes they don't understand whatever I have done in the yesterday's class. So it took some long delay to cover the next day topic. So that's why I don't go in that way. But yes, so tomorrow, whenever you will be coming to class, please understand these all binary, and we will be learning the IP addressing and what is a subnet mask. So this is tomorrow's topic. So everyone, please go through it. Okay, so yes, many I have already sent to you in the book over here. And if you need the book for IP addressing, I will be emailing all of you. I have to create one group for all of you where I will be sharing common resources so that you all will be availing those all. Okay.
Sure.
Yeah. Okay.
Okay then. Yeah. So I'll see you tomorrow by the same time, and take care. You just all need to send my send me the email. Ambrose, you also have to. I have shared my ID. You please just mail me over there. Okay. My whatever your ID is, just mail me. Say yes if I'm audible to you.
Sure. Yeah, audible.
Okay. So actually, yeah. Okay. Fine.
No,
Yes, you are
others
audible.
are silent. No one
All
else.
right.
Yeah,
Okay.
you are
Good
audible.
night for everyone, and see you tomorrow.
Okay,
Yeah,
see you
see you
tomorrow.
tomorrow.
Good night, man.
Take care. Bye.
Good night.
Thank you, ma'am.
Bye. Bye. Good night.